What's going on, everyone? Welcome back. Patrick here, and moving on to the next example, we got another trig limit to do. So we got the limit as x approaches 0 of sine 4x over 5x plus tan 8x. As I've done in the previous examples, going to be using some of these results. A lot of these results I actually showed how to get in the previous examples. So if you didn't watch the previous examples, make sure you do before this one. I put them in a specific order on the site, and I did that on purpose, just so we're building kind of the fundamentals. And so if we do run into one of these results, I'm going to go through it a lot quicker in this example because I'm assuming you've watched the previous examples where we go through those results in more detail. So we got the limit as x approaches 0 of sine 4x over 5x plus tan 8x. So what you want to do here is you want to rewrite this fraction. Now, just to do a quick review, if I have a fraction a over b, this fraction is the exact same as 1 over the reciprocal b over a. Because if you think about it, if I take 1, which is like 1 over 1, and I divide it by b over a, that's like 1 over 1 times a over b, which ends up being a over b. So if we have a fraction, we can always rewrite it as 1 over the reciprocal of that fraction. That's what I'm going to do here. I'm going to take this limit and I'm going to rewrite it as 1 over 5x plus tan 8x all over sine 4x. Now, why did I do that? The reason why is because now what we can do is we could take this fraction in the denominator and we could split it up into two separate fractions. And notice one of the fractions would be tan 8x over sine 4x, which you notice it's in this format here, tan mx over sine nx, which is just equal to m over n. Versus here, we can't split this up. So again, a little review of fundamentals. Whenever you got a fraction like this, a plus b over c, we can rewrite that as a over c plus b over c. But if it's the other way around, if we have c over a plus b, you can't rewrite that as c over a plus c over b, right? So it doesn't work out here, but here it's now in this format where we have that one expression in the denominator. We could split it up. Okay, so that's why I did that reciprocal part. So now the next line is going to be limit as x approaches 0 of 1 over, I'm going to put this 5x over the sine 4x plus the tan 8x over the sine 4x. Like that. And now what I could do is I can actually take this limit here and distribute it to the numerator and the denominator using limit laws. Whenever you have limit as x approaches a of f of x over g of x, you can rewrite that as the limit as x approaches a of f of x over the limit as x approaches a of g of x. So that's the limit law I'm going to use here. So I'm going to have the limit as x approaches 0 of 1 all over the limit as x approaches 0 of this entire expression, 5x over sine 4x plus tan 8x over sine 4x. Okay, so just distributed that limit at x approaches 0 to the numerator and the denominator. So continuing this up here, limit as x approaches 0 of a constant, that's just going to be what? That's just going to be equal to the constant, right? Limit as x approaches a of a constant is just equal to the constant. So this is going to end up being 1. And then over here, notice how we got the limit as x approaches 0 of a function plus another function, so we could distribute that limit to both of these, because the limit as x approaches a of f of x plus g of x equals the limit as x approaches a of f of x plus the limit as x approaches a of g of x. So I'm just going to distribute that limit here. So we got the limit as x approaches 0 of 5x over sine 4x plus the limit as x approaches 0 of tan 8x over sine 4x. Okay, so just used a bunch of limit laws in the last couple of steps. So took this, changed it to be this here. And now what I'm going to do at this step is I'm actually going to deal with both of these limits separately. So we know that this here, it's in this format. It's equal to m over n. So we know that this limit here is going to equal 8 over 4. But I'm going to show you the work again. It's just I'm going to do it a lot quicker than when we did it in that video, when we derived that result. But before we get into that one, I'm actually going to work with this limit first. So now this is going to be work on the side for this main limit. So we got the limit as x approaches 0 of 5x over sine 4x. And what we want to do here is we actually want to multiply this by 4x over 4x. And so what's going to happen is I'm going to take this 4x, put it over this sine 4x, and then I'm going to take this 5x and put it over this 4x. So I'm just going to interchange these. So we're going to have 4x over sine 4x multiplied by 5x over 4x, like that. Just took these, interchanged them. Now notice here, this x and that x cancel out. So we're actually just left with 5 over 4, which is a constant. And because that's a constant, we could actually take it out of the limit. Again, another limit law. If you have a function multiplied by a constant inside a limit, you could take that constant out. And we're going to be left with 4x over sine 4x. And then this result here, we know it's going to equal 1. We've already shown this a bunch of times. We basically have to take this and convert it into this format. And so we can do a change of variable. I'm going to let theta, I'll actually continue it up here. So I'm going to let theta equal 4x. And then as x approaches 0, that means theta is approaching 0. So I'm going to continue this here, and I'm going to rewrite this as 5 over 4. And then this limit I'm going to rewrite as the limit as theta approaches 0 of, remember theta now is 4x, so I'm going to have theta over sine theta. Now we got to get this into this format. Notice it's theta over sine theta, but this one's sine theta over theta. Now I've mentioned before that this is also equal to 1, but to show you the work again, just so you better understand, repetition never hurts. I'm going to do that same reciprocal law that I used. Remember the a over b? That's equal to 1 over b over a. I'm going to use that here. So I'm going to rewrite this as 1 over sine theta over theta, like that. And now we could use the limit law again to distribute the limit to this 1. So I'm actually going to do this in the same line. This could be the next line for you. Limit as theta approaches 0, limit as theta approaches 0. Use the limit law. Distribute it to the numerator and denominator again. That's just 1, and then this is in that format. That's just 1 as well. So we'd end up with 1 over 1 times 5 over 4. So this limit, which is this here, ends up being 5 over 4. Okay, so we showed the work on the side for that. So going back to this, we're going to have 1 over this ended up being 5 over 4 plus the limit as x approaches 0 of tan 8x over sine 4x. Now again, we know this is going to equal 8 over 4, or just 2 because of this result, but if you want to show a quick, what I'm going to do is I'm going to change the tan 8x to sine 8x over cos 8x. We're still going to be multiplying by 1 over this sine 4x, so I'm just kind of splitting everything up. And then what I'm going to do is I'm going to multiply this by 8x over 8x, and then multiply it by 4x over 4x, like that. Okay, so now I'm just going to mix these up a bit. So I'm going to take this 8x, put it over this sine, or put it under the sine 8x, so like that. These are taken care of. I'm going to take this 4x, put it over this 4x, over this sine 4x, like that. So these are taken care of. I'm going to take this 8x, put it over this 4x, so that's going to just be, notice how the x's here will cancel out, so that's just going to be a 2, right? 8 over 4, that's just going to be 2. And then we're just left with this 1 over cos 8x, like that. And now notice that we could take this 2 out, and then we could distribute this limit to these 3 expressions. So we'll have the limit as x approaches 0 of sine 8x over 8x, the limit as x approaches 0 of 4x over sine 4x. So this, and then the limit as x approaches 0 of 1 over cos 8x. So I know we've done this process many times already in the previous examples. Might be overkill. You may want to fast forward through these if you're already really comfortable doing all this. But again, I feel like repetition with this stuff never hurts. So notice that this here is actually in this format, but the m and the m are the same. So it's like 8 over 8, right? So we know this is going to equal 1. We can also do a change of variable like we did before. So we could let theta be 8x. So we'd have limit as theta approaches 0 of sine theta over theta, right? Which would be that result. So whichever way you do it, that's going to be 1. This here we can rewrite as the limit as x approaches 0 of 1 over the reciprocal of this, sine 4x over 4x, like we've been doing. And now notice that it's in this exact same format where this is just a 4 and that's a 4, right? Distributing with limit laws, so we know this is going to go to 1. Okay, so that is going to be a 1 as well. You can do a change of variable. And then notice this is going to be 1 as well. We could do a direct substitution here. Notice we can't do direct substitutions here because if we plug in 0 for this x, the denominator is going to be 0. If we plug in 0 for this x, we're going to have sine of 0, which is 0, which would make the denominator 0. But here we can, because we're going to end up with cos of 8 times 0, which is cos of 0, which is just 1. So we know this is going to go to 1 as well. So we're going to end up with 2 times 1 times 1 times 1, which we know is 2. And as we mentioned, makes sense that it's 2 because we have the tan 8x over sine 4x, limit as x approaches 0, that's in this format. Result is m over n, 8 over 4. Okay, so with all that work now, you would end up with 1 over 5 over 4 plus 2. And now it's just simple algebra. So you'd have 1 over 5 over 4 plus this 2, we could change to 8 over 4, so we have a common denominator. 1 over 13 over 4. 1 over a fraction is just the same as the reciprocal of that fraction. Let me just make sure everything's all good. Yeah. Right, so the answer for this is 4 over 13. Right, so we had to manipulate this a little bit get it into certain formats. We had a bunch of different limits, but then we were able to use those same results we got in the previous videos, ended up getting the numbers, and then the algebra 4/13 is the final answer.